Malaysia Green Building Council, also known as Malaysia GBC, is an organization that promotes green building programs, technologies, and design practices, aims to make Malaysia an eco-friendly and sustainability place on Earth. Malaysia GBC was founded in May 2009 by a group of passionate building consultants, academia, and representatives. Even since Malaysia's building has increased, the efficiency of resources used in each building was built with green in mind. Malaysia GBC is also supported and associated with most of the top industry institutions. In the year 2015, Malaysia GBC became an established member of the World Green Building Council and known to be the only organization in Malaysia to be supported by the World GBC. Malaysia GBC continues to be the platform that networks, promotes, educates, and most importantly, develops the sustainable, built into the land of Malaysia. With much more passionate industry professionals, we can make Malaysia a greener and better place on Earth.
BK, you may start now.
Thank you. Good morning, everyone. Welcome to today's webinar, Accelerating Business Decarbonization with Clean Energy and AI, organized by IGEM 2021 and Malaysia Green Building Council. Today, we've got a very exciting session of two speakers, both ladies, fortunately, one from Penang, Malaysia, and the other one from Taiwan. And I'll be going through the paces of what they're going to speak about in a short while. So let me start by introducing the topic, Accelerating Business Decarbonization with Clean Energy and AI. A study by the Chartered Bank stated that Malaysia-based suppliers risk 269 billion ringgit by not going green if they fail to curb their carbon emissions. Racing against the time to hit net zero carbon goals, corporates are increasing the pressure on their suppliers to become more sustainable. The path to net zero decarbonization is increasingly unavoidable for businesses. When do we start? The sooner, the better. To avoid the most devastating impacts of climate change, we must limit average global warming to 1.5 degrees C by reducing energy-related CO2 emissions in the short term. That means using the lowest carbon energy sources available for manufacturing, heating, cooling, lighting, and transport of goods and people, as well as for services. AI, or artificial intelligence, has great potential to accelerate our efforts towards decarbonization. It is the key enabler of a complex new data-related energy industry, a key magic tool to increase operational performance and efficiency. The low-carbon transition requires AI integration to ensure a stable grid with increased contributions by renewable energy, which may be intermittent by nature. As the energy industry utilizes more variable generation sources, the accurate forecasts of power generation and loads are essential to maintain system reliability, minimize carbon emissions, and maximize renewable energy resources. Hence, the success in embracing green technology advancement will certainly contribute to our goal to build back better as a recovery effort to reach net zero in a post-COVID world. With that introduction, ladies and gentlemen, I'd like to now introduce to you our first speaker, T.S. Regine Chu. She is currently the director of Yongyang Sdn Bhd, an experienced player in the solar industry in Malaysia. She is an experienced entrepreneur herself with a demonstrated history of business experience in the green solar energy and green building industry. She is accomplished in the roofing industry, solar industry, renewable energy, business planning, finance, sales, and engineering with strong professional entrepreneurships. T.S. Regine Chu is armed with an MBA in professional development. She participated in leading roles in related NGOs in Malaysia, as she is currently the Northern Chapter Chair of the Malaysia Green Building Council, or Malaysia GBC, which is an established member of the World Green Building Council. Ladies and gentlemen, we give you T.S. Regine Chu. Regine, the floor is yours. Thank you.
Good morning, everyone. Thank you, VK. Yes, hello, I'm Regine from Yongyang Solar Roof. So basically, we are the solar PV service provider providing one-stop building-related clean energy solutions for commercial, industrial, as well as domestic market. Yeah, so to resonate with the theme of this month under the NGA webinar with Malaysia Green Building Council today is climate change. So we'll talk a bit about how does carbon emissions affect climate change. Yep. So since the Industrial Revolution, you can see here, since the 18th century, we've been releasing a lot of carbon dioxide when fossil fuels were burned to produce electricity, to cool buildings, or to power up the machines. These carbon emissions are trapped in our atmosphere that causes global warming, which also causes climate change, which include melting of the polar ice caps, the rising of sea levels, and the disturbance of animals, natural habitats. As you can see here, polar bear is the victim of our the climate change, and extreme weather events, and so on. So this is, as you can see here, the ice loss from the climate change is the biggest threat to species like the polar bear. So we need to reduce the usage of energy, to reduce the carbon emission, and to prevent the rise of global temperature. Yeah. Let's zoom in further. Next slide. Okay, so where we are now currently in terms of the carbon emissions ranking. So I've got the latest data. It shows that Malaysia actually ranked 34th in 2009 in terms of the per capita consumption, which records at 6.9 metric tons carbon dioxide emission per capita. Yeah. So before this, we were actually higher in terms of the per capita, about 8.1, and now we have reduced to, so thanks to the our climate change effort. Yeah. So according to the Malaysian Green Investment Development Authority, MIDA, thriving RE technologies including solar, hydroelectric, and biomass. However, if you compare to other RE technologies, recent development in the solar PV, especially for the past 10 years, has led to a phenomenal growth in Malaysia and also worldwide. Yeah. To fight off the COVID-19 pandemic, as we know that countries have been flattening the curve, the so-called the spike in the infections. So similarly, we now have to flatten the climate curve too, the ever-growing spike in the carbon dioxide. As you can see here, under the climate pandemic, flatten the curve, we are advancing from the building low energy or high energy efficiency buildings to growing more trees, increasing renewables, and then we are moving to the era with zero energy building and nearly zero energy building, etc. And eventually, worldwide is going forward to advancing net zero carbon by 2050. Yeah. So this is to figure out how we can actually effectively reduce emissions. We need to first understand where our emissions come from. As you can see on the diagram on the left here, there's actually almost 3/4 of the emissions that is coming from energy itself, and whereas almost 1/5 from the agriculture and land use. This is a global data. What about Malaysia? We will see that on the diagram on the right, yeah. And similarly, we also will see that emissions actually come from many sectors. So in a way that we need many solutions to actually decarbonize the economy as a whole. Okay, let's look at the Malaysia on the context on the right. So currently, you can see that Malaysia is only about 8% renewable energy is generated from renewable energy, which is not including large hydro. If you're including large hydro, that is coming up to about like 23%. So, however, this means that almost about more than 70% of our energy generation currently is still coming from the coal and gas in our utility electricity mix. Next. So you can see here, this is actually the total greenhouse gas emissions from 1990 to 2016. As you can see, it's actually on the rising trend. Yeah. So the higher emissions were coming from the energy industries with an average growth of 6%. And within the energy industries, the electricity generation contributed. Okay, when we're talking about decarbonization, right? So we are going to discuss further. I'll share further in terms of the carbon emission. The GHG protocol actually separates carbon emission into 3 buckets, as you can see here on the right, scope 1, 2, and 3. So scope 1 is actually refers to the direct emissions, which is what is the direct emissions? These are the emissions that caused directly by the company-owned asset. Generally, it is also easiest to track and change, and such as facilities, equipment like boilers, furnaces, company vehicles, on-site landfills, chemical production. These are some of the examples. Yeah. What about scope 2? That is indirect emissions. These emissions are caused by the company consumption of energy purchase or consumption of electricity. So it's a purchase of electricity for heating or cooling. And this is actually indirect, and it requires tracking both on the company as well as the utility provider. So such as the electricity use, perhaps to power up your lights, computer, machinery, heating, steam, cooling, as I mentioned earlier. So, and these emissions is occurred at the electricity generation facility, which is usually fossil fuel combustion. Yeah. Now the third is a scope 3, which is the indirect, and it usually involves the value chain emissions. Indirect greenhouse gas emissions from the company, which is mostly from both upstream and also downstream activities. And they are usually they are not controlled or owned by the company. And some consider that as an optional item to track. And however, is actually consists a large source of company carbon footprint. So typically they are purchased goods and services, transportation and distribution, waste, traveled, energy and fuel, lease asset, etc. Yeah. So now we are looking at what are the programs that has carried out in Malaysia and still ongoing in Malaysia. So as we know that Malaysia experiences hot and humid weather with a lot of rainfall, and also but we receive abundant of amount of solar radiation. Yeah. So that's why applications involving solar energy has been gaining popularity in Malaysia due to the favorable climate conditions. So realizing this, Malaysia government have introduced several programs. Namely, the first program was feed-in tariff. Then eventually we move into net energy metering, self-consumption, and for the last scale, it's a large-scale solar. Yeah, and nevertheless, it comes with a RE incentive, and some of the example the scheme, especially by MIDA, to reduce the bill as well as to provide a fiscal incentive to attain a carbon neutral environment. So you can see here, Malaysia has a lot of resources in terms of renewable energy, biomass, solar, and hydro. At the COP15 held in Copenhagen, Denmark, Malaysia pledged to voluntarily reduce greenhouse gas emissions by up to 40% by 2025 compared to 2005. Yeah. So as I mentioned earlier, companies that investing in the NEM, especially to boost the renewable energy uptake, is entitled for tax incentive, namely the investment tax allowance. And then similarly, banks or financing institutions are becoming more offerings for solar power financing packages with attractive interest. And this will definitely help Malaysia to achieve the 20% of RE efficiency by 2025. Yeah. So growing sustainability and environment concern actually threatens the viability of our old business model, and this will cause them to pivot away from the fossil fuel. For example, we take here the N group case here. As you can see that it has a detailed roadmap to neutralize direct and indirect emission, which is associated with the purchase of electricity. And they will also how they plan to cancel out the carbon emissions generated from sources that doesn't own or control, covering areas such as supply chain, business travel, etc. This is just an example, perhaps. So the business demand for energy, clean energy, is actually rising because it totally makes business sense as well as environmental sense. To meet global climate targets and to remain competitive in the world driven by cheaper, cleaner energy, it is becoming the norm to power your business with renewables. As you can see, we follow the lead of environmentally conscious of Fortune 500 companies. Namely, there are more than 300 companies have joined RE100, meaning they pledged to use renewable energy 100%. And these are the industry ranging from food to fashion to brewing and batteries, where they commit to drive down the emissions. Collectively, these companies have combined revenue of more than $6 trillion, which is overall of 7% of global GDP. As you can see, these are the RE100 companies. Yeah, that is actually leading in terms of the decarbonization. So I would like to also touch a bit for some on the components in the solar PV system. So typically it consists of the solar modules. For some that already know, just briefly go through here. Solar modules that generate energy from the sun irradiation. So it doesn't use fossil fuel. That's why it's considered a low carbon resources. Yeah. Next, we have the inverter in typically a solar PV system that converts the DC to the AC power output. Because whatever power output from the solar module is actually DC energy. And but whatever we are using as well as the grid is actually AC. That's why we need a solar inverter as the device to actually convert the DC to AC for feeding into the electrical load and for direct consumption. Yeah. Next, we also need to consider, for some who would like to consider the adopting solar energy, roof design, and also roof loading is also another factor to be taken care of, especially on the due diligence checking of the roof condition and for the structural load calculation, etc. Nevertheless, in a system, we need to be equipped with a stable and also intelligent monitoring system coupled with a weather station. So Ms. Joyce will actually elaborate further later. So basically in the system nowadays is coupled with a cloud-based technology, with a smart AI fault analysis, all of this with the ultimate aim to constantly improving the efficiency and also to minimize the intermittence of the solar PV system nowadays to ensure that it's continuously running as long as the sun is out. Yeah. I would like to, when I'm doing this, some research, actually I find some interesting data, perhaps that I would like to share with the audience today is in terms of the, you can see here the amount of irradiation curve in Malaysia, 2019 and 2020. Yeah. So as we can know, especially last year, Malaysia government efforts have enforced the MCO law, which is led to closing most of the cities, industrials, recreation centers, and eventually it led to a situation, something like a curfew. Yeah. So the implementation of this law has resulted in the reduce of air pollution, reduce in a lower carbon footprint, as well as lower carbon emissions. As you can see here, there's actually a visible higher irradiation actually recorded in 2020 versus 2019. So the researchers actually suggest that this actually caused the maximum amount of sunlight to reach the Earth and radiating the solar panels in the solar PV system and lead to the increase in energy production. Yeah. So as we know, in this era, people are more aware of the environmental consequences of burning fossil fuel. Sustainability has become an ethical principle. Yeah. Both issues that actually encourage people to protect our nature environment, especially is becoming more obvious and the awareness is higher after a period like MCO. Yeah. As you can see here, the potential applications of this solar renewable energy in Malaysia is very high. As majority or typically most of the areas, especially on the northern side of Peninsular Malaysia, as well as certain states in the Sabah, is actually records a higher solar irradiation, which is as high as 5 hours. Yeah. So typically Malaysia is situated on the location which is near to the sun belt, near to the equator. So the amount of the sunlight irradiation is relatively higher. That's why it makes it very visible for the solar PV installation. Another benefit that for the solar PV system owner possibly could enjoy is you would have a double roof protection, because you will have those solar panels to actually protect on the rooftop temperature. And this will actually contribute slightly to reduce in terms of the air conditioning load, and thus also reducing the carbon emission in the long run. Yeah, as you can see here, there's relatively a difference in terms of the temperature, as about like 3 degrees Celsius in the area that is installed with panels and versus the area that is not installed in the panel. Yeah. As you can see here, where we can take some case study. So for example, like this is actually a industrial building. So taking the baseline of the carbon emission for Peninsular, which is 0.694 metric ton carbon emission per megawatt hour. So this building is expected with the PV installations expected to be decarbonized or reduce the carbon emission as much as 971 tons per annum. Yeah. So similarly, these are some of the different industries which is able to showcase the similar decarbonization with different tons of the carbon emission per annum. Well, because depending on the system size and also depending on the energy requirement. Yeah. You can see here, it can be adopted to any buildings as long as you have a good, suitable, feasible roof that is free from shading. Yeah. That's all for my short sharing today. So thank you. And you have any questions, can always contact myself or can drop an email to us at the email here. Thank you again for the opportunity to share with you today. Thank you.
Thank you very much, Regine, for that wonderful talk. It was very, very informative and opening of our minds. Right now, ladies and gentlemen, I'd like to move on to our second exciting speaker from Taiwan. I'll be introducing Ms. Joyce Bai. She's the co-founder of ThinkNario Limited. Ms. Joyce Bai is currently the Chief Marketing Officer of ThinkNario Limited, providing intelligent and scalable solutions based on machine learning and computer vision technologies. Specialized in PV monitoring systems and operating and maintenance management systems based on AI or artificial intelligence technology. She has more than 10 years of experience and exposure in the video surveillance industry, not only in Taiwan, but also in the European market. Ladies and gentlemen, I present to you Ms. Joyce Bai. Joyce, the floor is all yours. Thank you.
Hi, good morning, everyone. Thank you for the introduction, and thank you, Regine, for the renewable energy introduction as well. My name is Joyce, and I'm from ThinkNario, Taiwan. ThinkNario is a company offering based on AI PV monitoring system to apply AI technology in the solar farms. So today is really my honor to present here to share our experience in the solar business, to give you more ideas how to manage your solar business more efficiently by AI. Okay, as Regional already mentioned that, as we all know that climate change cause a lot of damage in economies and people's life and living qualities. And as we all know that renewable energy and the low carbon emission will be the key to slow down this climate change. And so nowadays, renewable energy become a popular topic in politics and industry, and of course in the IT industry. Okay, next one. So before I start, I would like to introduce Scenario, the company. Scenario is a company actually very young, and is an AI and IoT startup founded in 2017. And the mission is to reduce the gap between the AI technology in the industry. So what kind of, to reduce the gap between the information tech, which is IT, and the operation tech. And you can say it's kind of reduce the gap between physical and the virtual. And as we all know that IT technologies such like big data, mobile computing, AI, is become a booming topic for the past decades. However, how to apply this kind of new technology to the physical industry is still a big challenge. Okay, so let's talk more about the AI. When we are talking about AI, people can mention generally like artificial intelligence, machine learning, and deep learnings. And why AI becomes so popular and become realized in our real life is because we all know that AI booming is driven by the rapid growth of computing power. According to the figure you can see here, the GPU performance, this green line, has been increased more than 1,000 times in the past decades. So we can benefit from this tremendous improvement. So more data can be calculated and much more faster. The calculation can be much more faster than before. So that the complicated AI algorithm can become a possibility. So the complicated AI algorithm can be created by engineers much more easier than before. Okay, so let's talk about AI a little bit. There are two kind of characteristics when we're talking about AI tech. The first one is machine learning, and the second one is deep learning. So you may ask, what exactly the difference between them, the traditional machine learning and deep learning? Usually, if you want to make the AI system to identify, is this photo a dog or not a dog? Firstly, you have to build the model, and you have to offer a lot of photos to make a people or a bunch of people who to identify, is this photo a dog or not? So the person who will identify some features, what we say is like a feature extraction, and people will do this identification first, and the computer will do the rest of things. And what's the difference between machine learning and deep learning is that deep learning is more advanced. Deep learning will do the feature extraction and classification together by computers. So it's less people's involvement. So, people make a mistake. So it becomes less people involvement to make sure the data will be accurate. And of course, because computer have to do the job, so it requires much more data volume. And we all know that from the previous slide here. Okay, so the GPU performance nowadays can handle this a lot of data volume. Okay, let's see what people expect from the AI in solar. For example, there are mainly two categories. Will be from the OEM perspective, try to reduce manpower, technician training cost, try to reduce their time wasting in troubleshootings, reduce the ineffective activities, and try to improve the quality of equipment or the lifetime of their equipment. And of course, from the financial perspective, that they want to have the more accurate IRR evaluation, or try to improve their IRR. And like what Reggie mentioned, that they want to do the forecasting about the energy production. Okay, let's see what AI can do from the O&M perspective. The real case we have here is about the cable failure of the wiring. As we all know that if something happened from the inverters, you can get the alarms from inverters. And what if something happened, or something error, or something broken in the PV modules or in the cable? Can you find? Let's take a real example here. This is a very normal curves we have in the PV monitoring. The red one is irradiance. The blue one is the power production. And this project is around 500 kilowatt capacity and 14 inverters from the noontime to the 1 p.m. So can you tell what's going on or something wrong here? And even the experienced engineers or who monitor the PV site for many years, they cannot find the problems, because the inverter didn't show you any alarms. And however, by AI, the AI can tell you, hey, there's one MPPT circuit was dropping around 18% suddenly. And like what I mentioned, inverter didn't trigger any alarms. Okay, so we asked the engineer to go on site to check, and he found out, oh, there's one wiring or some cable burned out. Okay, so in this case, most monitoring system will be unable to detect the circuit issue, because monitoring system usually take the alarms from inverters. And this kind of chart are very difficult to read, because the curve seems normal. However, in this case, the AI already helped the customer to save around 1.6% the year revenue. So it's around $1,500. So not to mention, if the capacity is bigger, the total amount revenue will be much more bigger. And another real case is about the shadings. We all know that the PV sites are far away or remote from where we live. And what if there are some trees or buildings or poles growing up, and you don't know what happened, because you don't know why. So this is a real case AI can help you to solve. I would like to explain a little bit about this heat map. This y-axis shows you inverter 1, 2, 3. And this horizontal axis shows you time from 5 a.m. to 7 p.m. And the color shows you the inverter performance. So in this time, there's no shading issues in summer. So you can see they are quite even. The performance are almost the same between inverters. And however, when it goes to autumn, you can see because the sunlight is a little bit changing their angle. So you can see there's one inverter seems less performed than others. And not to mention in the winter time, the inverter number 1 seems no production at all. And in this case, you will not find out. You just think, oh, maybe it's some problem about the inverters or some problem about the panels. It's very difficult to figure it out. And especially in the cloudy day, because cloudy day, all the inverters are not doing the job. So you don't find out what exactly the problem. And however, the AI system can tell you, hey, it's because of the shadings, like this. So it's a real case. It happened when the AI tell you, hey, it's because of the shadings. You better go to check whether it's a trees or a grass. And when the customer go there and he see the photo like this, and he immediately take the action, which is cut off the trees, right? So the power production and get back to what you should have. And let's take a look about what's the technology behind this and what is the AI can do. So actually, we all know that we call that time series data from solar plant. It's kind of high dimensional data such as DC, AC voltage, current, active power, reactive power, and power factor frequency. A lot of data, right? So what AI doing is that try to do the dimension reduction because there are too many dimensions and try to make it reduce to the 2 dimensions. And we can do the unsupervised learning. You can understand what does that mean, unsupervised learning, by its naming. Unsupervised learning means that we don't have to correct the answer or monitor the AI system because it's AI. They will correct themselves they will correct the data, correct the answer, correct themselves by themselves. So this is all the job the computer are doing that instead of people. Okay, so this is a real case again. Let's take the inverter performance, for example. Like what I mentioned, the y-axis shows you inverters and the horizontal shows you time. So it is suspicious here in this square that the output power is a little bit lower than other inverters. And here is a blue one. And this is the data when putting in the computer, and it shows like this. So you see, the AI can very easily to find out the potential loss here. Okay, even based on the inverter data. So by applying the dimension reduction and unsupervised learning tools, this suspicious data can be find out very easily. Okay, and what AI can do next. The AI is not only doing find out what's the problem. The AI can also categorize the failure. For example, the AI will know, oh, this is because of the fan fail. This is because of the derating, installation, shadings, and etc. So those are AI can do. Okay, so I talk about a lot of AI, but there is a very key foundation for AI is data. So you must have the clean data and right data to fit in the AI machine to let them do the job. So data accuracy are really important. So for example, what we have to do before we put it in the AI system, we all know that the monitoring system sometimes will be affected by the internet. Sometimes internet is broken or sometimes internet is unstable. And we had to do one thing is called a data timestamp to make each data meaningful with time. So if the data is like this one, the upper chart like this one, during 11 to 3 p.m., there is no data because of the internet broken. And when internet coming back and the data will become like boom, this. And for the AI system, this is really like a garbage data. So this kind of garbage data will influence the AI performance for sure and the accuracy. And what about another thing about data accuracy is about the irradiance and the temperature and wind and etc. According to IEC standard, that if you want to have the accurate monitoring, you have to have the time sampling time interval for 3 seconds, because we all know that. Let's take the irradiance for example. When we are counting the irradiance, we are counting the area of this irradiance curve. It's about this area. So if we retrieve the data based on 5 seconds or 6 seconds, the result will be big difference. Like what? Okay, like this. If we retrieve the irradiance data based on 1 second, okay, there's 0 error, okay? But if we retrieve the data by 10 minutes, you probably have 11% error, interval. Okay, so the data accuracy is really important when we are retrieving the data. Also, I would like to apply the IEC standard that, for example, in this kind of bar, 6 a.m. in the morning, when we get the data like this is we call that funny data. So Scenario try to apply some standard and make it real happen in our AI system, try to remove invalid readings. When we say readings, it's like invalid data. And also, sometimes data can be missing because of the inverter connection status and etc. And we apply the standard to have the treatment of missing data. Okay, go next. So if a good monitoring system applied with AI, it should be the flow or let's say ecosystem like this. You will have daily monitoring system and you will get the alarms not only from the inverter side, but also from the AI. AI will do the job for you. And the AI will, based on this, and the system will give you the data analysis to show you the result about the production, about the forecast. And of course, you will do the daily job like inspection and OEM actions. And those can be your actions react to the monitoring system. And this can be kind of AI tool or AI input back to the system again. So Scenario is a company offering AI monitoring system for the PV, and we try to make this kind of monitoring system, OEM system with AI technology and with more comprehensive working flow together. And the last thing is that we offer this kind of AI tech, AI diagnosis around Taiwan, Malaysia, Thailand, and the Americas. So this is about my presentation. And if you are interested about more AI application in the PV sites, you are much more welcome to contact us. Okay, thank you.
Thank you very much, Joyce. That was really, really interesting. This is one area where it is always seems like magic, but it's not. It's highly technical and completely explainable. With that, ladies and gentlemen, we should really go to a Q&A session. And I have a few questions to ask the speakers. The first question I'd like to ask would be directed to Ms. Regine. Regine, you know how many gigawatts of energy that Malaysia produces, and you know exactly what portion of that is renewable energy. In fact, if I remember correctly, but please correct me if I'm wrong, it would be only about 6%, if I'm not wrong, currently. And on the other side, it is also true that PV is electricity from PV is cheaper to produce than gas and coal mix, what TNB is doing now. Not too long ago, we had a breakthrough in price. Now, this doesn't make any business sense to me. I'm completely confused. One is cheaper to produce, but we use the one which is more expensive. That is not business-like. Could you please explain to us a little bit behind the scenes as to why this is happening and how it can change? Thank you.
Thank you, BK. Yeah. Sorry, I think my background, there's a sound. Yeah. Okay, yeah, I kept, so sorry if I capture your questions correctly. You're talking about, for the solar PV systems cost, it has been come down a lot for the past 10 years. So it has been recorded of like more than 70% drop in terms of the prices. So this is actually making the PV systems more affordable than the fossil fuel. As we can see, some people call it like reaching the grid parity. Yeah. So as well, I think there's one more consideration is the solar PV panels is installed and then it has a long lifespan as long as like 25 years and more is possible. So with this, we are looking at the levelized cost of energy, so which is able to benefit by the adoption of like technologies like solar PV. But nevertheless, our country has been using coal and gas. You can see as what in my previous slides earlier, that we're using much of this power generation from the coal and gas still. Probably we need to go back to the history because back then solar PVs since solar PV is coming from, it's actually a space outer space technology that we bring back to Earth. So the price back then was not very affordable in a way. But over the years, with the technology advancement, efficiency improvement especially, so all this actually has making the renewable energy like solar to be more competitive than the fossil fuel. So I think this is actually the major outbreak as we can see here. Yeah. Nevertheless, we're still using the power that's generating majority as much as 70% from the coal and gas. We could see that the grid utility side, they are integrating more and more renewables into the electricity mix. Yeah.
Thank you for that, Joyce. Hopefully in the future, we can find an accelerated expansion of solar PV deployment to substitute the place of fossil fuel. Joyce, I'd like to ask you the next question. This is the burning question for everyone who mentions the words machine learning and AI. Are you going to kick us engineers out of our jobs? Now, I know that AI is coming into the fore in global technologies very rapidly. And it is very worried. For example, the example you stated just now of detecting the broken wire when one of the many inverters were not, I could have trained my dog to go and detect that wire. It's so simple to do that. I don't need an engineer to go and check it. That is because at the back end, AI has done all the diagnosis and pinpointed where the fault lies. Well, I'm joking when I said my dog. I could have had a very low-level supervisor or technician, rather, to go and rectify the mistake. And there you don't need an engineer. How would you think that AI is going to address this issue in the future? Thank you.
Okay, when people say, okay, when the AI take over people's jobs or replace like people's hands-on job, my answer will be no. We try to apply AIs because we know that the PV sites are far away from us, and we want to save people's time and make their job more efficiently. After all, if AI diagnose something wrong or broken, we still need the engineer to go on site to fix it. And however, when we are doing the AI modules, we still need the know-how input from the on-site engineers. So it's not like a machine or a computer are doing everything. No, and excuse me, like what I mentioned that when we want to build this kind of machine learning or AI models, we need people or customers or engineers input to tell us, okay, when this kind of curve happen, and that is because of shadowing. And this kind of a lot of experience and know-how technology will be collected massively and into the system and let the computer do the job, instead of they say, oh, okay, AI will in charge of the world and people, you don't need to work. No, it's not like this way. Yeah, so I think it's like a 1 + 1 bigger than 2 or even more. Yeah, so this is how we see the AI can do. So because of this kind of mindset or ideas that our company, even though we are IT company and we work really closely with the customers, the on-site engineers or the field engineers. Yes.
Thank you very much for that. Joyce, I would like a follow-up question. These machine learning and AI which you speak about, they are very, very crucial and important parts of another bigger word which I recently heard, but I'm not very clear what it means. And this word is called digital twin.
Oh, okay. Yeah. Digital twin. Yes.
So could you explain a little bit about the relationship between AI and machine learning and digital twin? Because that is a gray area for many of us. Any idea?
Okay, I think digital twin is more close to the blockchain. Okay, it's more like a security, more like a cyber security, or more like self proof about the data is correct. Yeah, but for the AI wing, I mentioned in the previous slides, is more like to diagnose what's the problem, to point out what's the point about. But the digital twin is like to make sure the data is accurate, or to more like a blockchain is like you cannot change the data, edit the data. Yeah, so I will say blockchain or digital twin is like the first step or the step to do the AI. But the AI is more like a general idea to include those kind of computer jobs, I will say. Yeah.
Thank you very much. That gives me clarity in my head now. Regine, I'd like to ask you this next question. The next big thing in solar PV. I believe, and correct me if I'm wrong, that the next big thing is facade PVs on the facades of buildings. Could you please tell us a little bit about where this technology is and when it will, importantly, when is your prediction that it will reach the performance required where it can become commercially viable? Instead of putting glass on the surface of buildings, we are able to put solar PVs. What's your thoughts on this? Thank you.
Thank you, BK. That is a very interesting question. So I would say that in terms of the PV panels for facade, it has been applied in foreign countries, not in tropical countries. Being said that the consideration was the sun position. Yeah, the sun position of our country here is on top of our head, so it's like 90 degrees up. But whereas for northern hemisphere, southern hemisphere, the sun is actually on lower. Actually, the position is lower. So whereby even on the facade, it can actually absorb the direct sunlight. But for in Malaysia, I would say that the absorption is optimized on the flat level and not on the vertical level. But nevertheless, we see that with there's both factors whereby it comes to how to be able to, correct me if I'm wrong, I get the question correctly, is how to be feasible or maybe commercially viable to be applied on the building facade applications. It very much depending on the levelized cost of energy And that also comes to another factor whereby the upcoming of the solar PV technologies, probably you have heard of like the thin film or the die type of solar cells. So currently it's not a commercial products. Yes, I would say that is, but I think that with the technology advancement in these related technologies, eventually it will actually provide a feasible solution in the future. Yeah, and not there's also another technology called perovskite. So these are all the new technologies that is coming behind. But of course, currently, as you can see, even in my previous presentation, it's mostly on the rooftops, the typical flat panels, because these are the proven stabilized performance. Yeah, and then with minimized intermittence. So that's how, but I would say that nevertheless, there's a future for these upcoming technologies to come and actually to be able to adopt even for a facade. Yeah, with a justified investment. Yeah.
That's very exciting. So we have got a lot to look forward to in the future with more applications of PV on buildings. So in the interest of time, ladies and gentlemen, and to close this this interesting session, I would like to ask two rapid questions to our foreign speaker, Miss Joyce. And these two questions, if you could answer them together, would be, what is the accuracy of AI diagnosis and how long will it take to train the AI model? Could you please give us some information on that? Thank you.
Okay. The first question I will answer about how long it takes to train the AI model. Usually it takes around 6 months, but it depends on what kind of AI diagnosis we're gonna have. But the longest time will be 6 months to train the models. And the second question is that how about the accuracy of the AI? I will say it depends on the regions. So, and also the inverter personalities. So currently, according to our experience, the accuracy can be reached to around 98%. Okay.
Yes. I think this is essentially machine learning. Machine learning also improve the response over the time. Yeah.
So it's about 98% accuracy and about 6 months. Would you say that's the gist of your answer?
Yes.
Thank you very much. Ladies and gentlemen, that brings us to end of this session. I would like to thank the organizers. I would like to thank iGen 2021. And most of all, I'd like to thank Ms. Regine Chu and Ms. Joyce Pai. Thank you very much for all your contribution and your interesting speeches, and hope we will catch up again on another interesting session like this. Thank you and bye.
Thank you, everyone.
Thank you.
Bye-bye.
Bye-bye.